In this video, we're going to learn how to divide rational expressions. So remember, when you divide fractions, you can find the quotient or the answer by multiplying by the reciprocal. You have learned this expression maybe as keep, change, flip. So when we have two fractions and we're trying to divide them, to find the answer or the quotient, we're going to take the first fraction, keep it, change the division sign to multiplication, and flip this second fraction, and then multiply across like we know how to do before. We can do the same with rational expressions. So when dividing rational expressions, we follow the following steps. So first off, you're going to keep, change, flip. Then you're going to factor all of the expressions if possible. Then you're going to cancel out anything that you can, and then finally multiply across. So let's see a few examples. In this first one, we're going to keep the first fraction the same, change the division sign to multiplication, and flip the second fraction. Now in this example, there's nothing that we can factor, so now we're going to try to cancel. So this x plus 4 and this x plus 4, since one's on the top and one's across on the bottom, we can cancel them. And then we're just left with our answer, which is x minus 7 all over 6. Let's try this second example. So we're going to keep the first fraction the same, change from division to multiplication, and flip the second fraction. And right here we're missing a plus 35, so add that in. Now in this step, we can factor as much as possible. So our first part, we can't really factor the 2x squared over x plus 5. But now we can factor this second part by saying what multiplies to 35 and adds to 12. So that's going to give us an x plus 5 and an x plus 7. And now in the bottom, we can't factor it that same way, but we can factor out a GCF. So if you notice 2 and 8, the GCF is 2. So we'll take out a 2. And then if we take out a 2, we're left with x plus 4. Now we're going to cancel as much as possible. So this x plus 5 can cancel with this x plus 5. This 2 can cancel with this 2. Remember, since this is over multiplication, we can cancel them. We couldn't cancel if it was just addition. So now we're going to multiply across and see what we are left with. So we're left with x squared times x plus 7 all over x plus 4. And now finally, we're going to simplify by multiplying this term out. So we'll get x cubed plus 7x squared all over x plus 4. And there's our final answer. Let's try a few more examples. So in this next one, as usual, the first thing we're going to do is keep, change, flip. So keep the first fraction, change to multiplication, and flip the second one. Next up, we're going to factor as much as possible. So over here, we're going to have v minus 6 times v minus 6 all over v minus 6. And remember, we can only cancel one pair at a time. So just because there's two v minus 6's, we can't cancel them both. We can only cancel one pair because something divided by itself is 1. And so then our final answer, we are left with v minus 6 over v minus 10. Let's try another. We're going to keep the first fraction, change to multiplication, flip the second fraction. Now we're going to factor as much as possible. So 1 over n plus 10. This 3 and 30, the GCF is 3, so we'll take out a 3. And then in the inside, we're left with n plus 10 all over 3. Now we're going to cancel as much as possible. 3 divided by 3 is 1. N plus 10 divided by n plus 10 is 1. So now you notice this whole second fraction kind of got canceled out. That doesn't mean that it's 0. It means that it's 1. Because remember, when we cancel, we're really just saying it's equal to 1. So then in the end, we're just left with 1. Let's try these last two. First off, we're going to keep change flip. So n squared minus 4n plus 3 all over 8n minus 8 times, and now we're going to flip 4n minus 36 all over 4. Now factor. What multiplies to 3 and adds to -4? Well, that would be -3, -1. So n minus 3, n minus 1. We'll factor out an 8 on the bottom because that's the GCF. We'll factor out a 4 over here because that's a GCF of 4 and -36. And then we'll have a 4. Now let's cancel as much as we can. We can cancel the n minus 1 and n minus 1. We can cancel the 4 and the 4. So now we multiply across. N minus 3 times n minus 9 all over 8. So now we're going to FOIL out that numerator to get n squared, and then a minus 9n minus 3n will give us minus 12n. -3 times -9 is plus 27 all over 8. Let's try this last one. So we're going to keep change flip. Change to multiplication and flip the second fraction. Now factor as much as possible. In this first one, I can take out a 3, and I can also take out an x. And I'm left with x plus 6. On the bottom, I can take out a 7, and I'm left with x minus 5. On the top, I can also take out a 7, and I'm left with x minus 10. And on the bottom, if I ask what multiplies to -60 and adds to -4, is going to be x minus 10 times x plus 6. Now we cancel as much as possible, so we're going to look, we'll see we have an x minus 10 and an x minus 10. We also have an x plus 6 and an x plus 6. We also have a 7 and a 7. So then in the end, we're left with 3x all over x minus 5.